Okay, hello everyone, it's Salar and we are in part 63 of our tutorial writing a real-time operating system. In this part, I want to talk about another facility in our real-time operating system, queue or user queue. Okay, in this part, we are gonna know what is queue and why do we need to use queue in our real-time operating system and our projects. Okay, so this is the first question. What is user queue or queue? Okay, to answer to this question, let's see this slide. How do you transfer, read or write some data between thread and interrupts? Okay, assume you have two thread 1 and thread 2, and you want to send some data from thread 1 to thread 2 or from thread 2 to thread 1. Okay, you want to send some data from a thread to another thread or from an interrupt to a thread or another interrupt. Okay, how do you transfer some data between threads and interrupts? The simplest way is using a global variable. Okay, you have access to a global variable from each part of your code. Okay, so the simplest way is using a global variable. By a thread, you can write to a global variable, and by another thread and interrupt, you can read that variable. Okay, so the simplest way is using a global variable. Like here, assume you have a global variable array or a simple variable or a struct, any global variable. Okay, a thread or interrupt can write or sum data in a global variable, and a thread or another interrupt will be able to receive those data. Okay, because you have access to a global variable from each part of your code. Okay, this is the simplest way, but this way has some problems. The first problem, assume more than one thread or interrupts want to write in a global variable. Okay, more than one thread or interrupt, because this global variable can be shared between some threads or interrupts. Okay, assume for example another thread, for example thread 1 wants to write to this global variable, and thread 2 like thread 1 wants to write to this global variable. So this global variable shared between thread 1 and thread 2. Okay, and assume at the same time two thread, or for example one thread or one interrupt wants to write some data in global variable. Or for example, this is the better example, assume thread 1 wants to write some data in global variable, and between completion of writing process, thread 1 wants to write some data in a global variable. For example, assume this is an array, and thread 1 wants to write some data in this array. Okay, assume thread 1 has written some data in first and second element, and at this time you have context switch, and after that another time thread 2 wants to write in this global variable. Okay, after context switch, thread 2 wants to write in the same global variable. You will have conflict. Okay, assume more than one thread or interrupt want to write in the global variable. You will have conflict because global variable is a shared resource. Okay, it's a shared resource. Okay, and in shared resource you may have conflict. Or another problem, assume before completion of write stage, okay, assume you have an array and this array has 4 cells and thread 1 wants to write some data in this array. After writing some data in first cell and second cell, first element and second element, you have a context switch, okay, and after that thread 2 wants to read from this array. Thread 1 doesn't complete the write stage, needs some time to complete the write stage, right, in this elements, okay. But before completion of write, assume you have context switch and operating system jump to thread 2, and in this time thread 2 wants to read this array. This is a problem. Assume before completion of write stage, a thread or interrupt want to read from global variable. Okay, this is another problem. Writing and reading in a global variable is the simplest way. As I said, it's the simplest way to implement queue. But it's not the best way. It has some problems. So how can we get rid of these problems? By using of 2 semaphore. By using of 2 semaphore, send semaphore and receive semaphore, okay? You will be able to get rid of these problems, okay? You can get rid of these problems that I said. First, conflict between 2 thread or interrupt and read before completion of write stage. By using of 2 semaphore, you can get rid of these problems. But how? Let's see how can we use this semaphore to resolve our problems. Assume you have 2 semaphore. Semaphore 1 is send semaphore and semaphore 2 is receive semaphore. Okay, the max value of send and receive semaphore is 1. But the initial value of send semaphore is 1, but the initial value of receive semaphore is 0. Okay, when you create a queue, you must create 2 semaphore, send semaphore and receive semaphore. The maximum value of both of them is 1, but the initial value of send semaphore is 1, but the initial value of receive semaphore is 0. How can I use these semaphores to implement a letter queue? In this way, when you want to send some data in queue or write some data in queue, okay, queue is a buffer. Queue is a buffer and you want to send some data to this buffer. First, you must get send semaphore. A thread must get send semaphore before writing to queue, before send some data to queue. By this work, we can prevent from conflict, okay? We can prevent from conflict. Because a thread or interrupt has to get send semaphore before write some data or some information in queue. Okay, before writing some data in queue, a thread or interrupt must get send semaphore. This work prevent from conflict. Okay. After get the semaphore, thread or interrupt will be able to send some data in queue. And after completion of write stage, this is write stage, send some data to queue. After completion of write stage, the code release receive semaphore. release receive semaphore. Because the initial value of receive semaphore is 0, no thread or interrupt will be able to read from semaphore, to read from queue before write stage. Before write stage, no thread or interrupt will be able to read from queue. But at this time, when you release the receive semaphore, a thread or interrupt will be able to read from queue or receive some data from queue. And this is the implementation of read from queue or receive from queue. Okay, this is the implementation of send to queue, and this is the implementation of receive from queue. First, you must get receive semaphore. This is help us to prevent read before write stage. This part of code helps us to prevent read before write stage. Okay? Because the initial value of receive semaphore is 0, and in this stage, after write stage, the code must receive the release the receive semaphore. Okay, after get this semaphore, you will be able to receive some data from queue. Okay, in read stage. Okay, in read stage. After read stage, another time queue is free. Okay, after read stage, another time queue is free, and another time you can write in queue. So you must release send semaphore. Okay, you can release send semaphore because after this stage the value of semaphore count is 0. Okay, because the maximum value is 1. After this stage, the value of semaphore count is 0, and you will not be able to write in semaphore in queue. But after read stage, another time queue is free, and you can release the send semaphore, and you will be able another time write some data in queue or send some data in queue. Okay, so by using a semaphore we can resolve these problems. Conflict between two thread or interrupt, or reading before write stage. And since user queue implemented by semaphore, you will be able to use that from interrupt. Okay, from interrupt you can send some data to queue or receive some data from queue. Okay, and as you saw in previous slides, user queue hasn't been implemented in kernel space and implemented by semaphore. User queue, it's not implemented in kernel space. For example, in user queue we don't have kernel space system call, or we don't have a unique system call for send queue or receive from queue. Okay, because of that I named it user queue. It's implemented in user space by using of semaphore. Okay, and it's not for queue. We don't have a unique system call, for example, for send to queue or receive from queue. Okay, because write a bunch of data in queue or read from queue. For example, assume you want to send 10 kilobyte data to queue, or you want to receive 10 kilobyte of data from queue. Since write a bunch of data in queue or read from queue is a time-consuming process, implementing queue in kernel space is not a good idea. Because of that, I've implemented that in user space. Okay, so now let's see the implementation of user queue. I've implemented user queue under this commit, user queue addition. Okay, this commit, user queue addition. I've added user queue in our real-time operating system. Now let's see the implementation. I've implemented user queue in this C file, user queue.c. Okay, user queue.c. For example, for user queue get name, as you see, we don't have user queue get name system call kernel space functions. Okay, we don't have, for example, for these functions and for these APIs, we don't have kernel space functions, because I said the user queue implemented in user space. Okay, you don't have kernel space system call. Okay, what are the APIs in user queue? First, user queue get name. By using of user queue get name, you can get the name of a queue. By using of ID, like before, you can get size of block. Okay, what is the block? For example, when you want to send some data by a thread to a queue, you need to allocate a block. For example, assume that the size of block is 128 bytes. Okay, this is the block that you use to send and receive some data. This is the block size. Okay, by using a user queue get size and an ID, you can get the block size of your queue. By using a user queue create new, you can create a user queue. You must get a name to your queue and a buffer size. What is the buffer size? This size. Okay, size of this block. You must give a name and a buffer size. Okay, and for each queue, the operating system create a send semaphore that its maximum value is 1 and initial value is 1, and create a receive semaphore. The maximum value is 1 and the initial value is 0. Okay, by using of user queue delete function, you can delete a queue. Okay, the implementation is so simple. By using of user queue send, you can send some data to queue. You can write some data in a queue. You must give the ID of queue. You must give the buffer address. What is the buffer address? For example, assume this is the queue buffer, and in your thread, for example thread 1, you have a bunch of data. Okay, for example, here is thread 1 buffer, and you want to write this block in queue. The address of this buffer, in your thread or in your interrupt is the buffer address of buffer. Okay, it's the buffer address. And buffer size. What is the buffer size? The size of this buffer. The size of this buffer in your thread or in your interrupt is buffer size. And after that, timeout. What's the application of timeout? I will say you. As I said, by using a semaphore, you can implement the read stage. First, before, this is the implementation of this slide. First, you must get send semaphore. First, you must get send semaphore. Okay, and the operating system use timeout here when you want to get send semaphore. Okay, first you must get the send semaphore. After that, write your data in queue by using of memcopy, and after that, release receive semaphore. After that, release receive semaphore. Okay, by using of this simple function, you can implement user queue send to send some data in queue, and another time implementation of user queue receive to receive some data. First, ID of the queue that you want to receive from that, buffer address in your thread or in your interrupt, size of data that you want to get from queue, and timeout. Okay, like queue send. And when you want to receive some data from queue, first you must acquire the receive semaphore. You must get receive semaphore. After that, copy the data from queue to your local buffer, okay, and after that, release send semaphore. Okay, release send semaphore. In this way, easily you can implement the queue in your real-time operating system. Now let's see an example. Here is an example. Like before, I have two threads. The priority of thread 1 is normal and priority of thread 2 is low. Okay, and I have a user queue. When you want to use queue, first you must define a ID for that queue. Okay, like thread, like semaphore, like matrix, like before. Okay, in this way you can create a user queue by using of this function user queue create new, the name of queue and the size of block in your queue, the block size in your queue. Okay, this size is size of the queue buffer. Okay, for example, at this time 16 bytes. Okay, at this time 16 bytes. When you want to send and receive some data in queue, you can use user queue receive and user queue send. At this time, I want to send some information and some data. I want to send this array, 16-byte array from 0 to 15. I want to send these data from thread 2 to thread 1. Okay, by using of queue, I can send this array, the 16-byte array in Q1 and read this data from thread 1. Okay, so let's run this example. Okay, now I'm in debug mode and I want to run my code because the thread 1 has higher priority normal than thread 2. The operating system first jump to thread 1. Jump here. Now thread 1 wants to receive some data from queue, but the queue is free. And at the first I said the initial value of receive semaphore is 0. So if thread 1 wants to receive some data from queue at this time, the operating system put this thread in waitlist. Okay, if I run this line, the operating system put thread 1 in waitlist and jump to thread 2. Now thread function 2 wants to write some data in queue. Okay, and release after writing some data. It release receive semaphore. Because after writing some data, the operating system release receive semaphore, the operating system immediately jump to thread function 1 because thread function 1 has higher priority. Okay, if I run this line, the operating system jump to thread function 1 and receive data from queue in this array, this local array. Okay, now in thread function 1, in array I have these data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, now I have these data in this array. Okay, by using a queue, I can send some data from a thread to another thread. Okay, so in this way I can send some data from a thread to another thread or to an interrupt, or from an interrupt to another interrupt or another thread. Okay, so this was the user queue and implementation of user queue. Thank you very much to see me and see you soon.